So now we know where JavaScript came from, but let's go back to a question that's probably on a lot of your minds right now. What are you thinking? You're thinking, JavaScript outside of the browser? Really? I mean, I thought JavaScript was really just about DOM manipulation. I thought JavaScript was how we made AJAX requests. What does this mean, this idea of headless JavaScript? Well, in fact, if this is your mental model of JavaScript right here, this big kind of undifferentiated blob, you could be very confused by that notion. But in fact, when I look at JavaScript, this is how I look at it. I see it as three equal parts. We've got the language itself, the keywords and the core concepts. We have the platforms that it can run on, and then we have the APIs. The APIs are the third-party libraries like jQuery or Angular or underscore. Now, we've been talking about the platform up to this point. This is why we're able to say now with great confidence that Node.js is Chrome's JavaScript engine, it's V8. But let's spend a little bit of time now talking about JavaScript, the language. Because one of the identifying factors of the mean stack is we're using this language pervasively throughout the stack. We're using JavaScript in the browser, obviously. But we're also running JavaScript on the server, we're running it inside of the web server, and we're even running it in our persistence tier. So JavaScript, the language, is what you see right here. It's wonderful that JavaScript, the language, is able to fit on one slide. And these keywords that you see here, this is what you're left with when you're asked to make a language that looks like Java and doesn't include classes. The keywords you see here should look very familiar to you if you're a Java developer. Of course, by extension, these keywords should look familiar to you if you're a C or a C++ developer as well. The keywords you see here allow you to do things like if, then, else. It allows you to do for while loops. It allows you to do try catches. As a matter of fact, all the keywords here are available to you in Java except the two in the upper right-hand corner, var and type of. Because that var keyword is very indicative as to where this language is going to take us. This is how we declare all of our variables. And since JavaScript is a weakly typed language, we need to use the type of keyword periodically to figure out what our variable types in fact are. So most of the angst that comes to mind when you're thinking about JavaScript and specifically about browser incompatibilities are in fact not due to the language, but due to the browser. All of the things we think of, the navigator and the window libraries, the AJAX requests, the set timeout, all of the DOM manipulation, document get elements by ID, get elements by tag name. All of these are in fact not part of the core language, nor even the platform. These are all APIs provided to us for the platform. Now that we have a mental model of our browser in place, we can expand it a little bit and see, in fact, that Navigator is a library we use to deal with the browser itself. We can also see a bit of the heritage of the language in this. Ironically, we use Navigator to manipulate the IE browser and the Firefox browser and the Safari browser and the Chrome browser as well. The window, in fact, is what you use to manipulate the window, and now that we have tabbed browsers, the window is what you use to manipulate the tabs as well. And the document, there's our DOM, the document object model. But these APIs are provided by the browser as a link between the JavaScript engine and the render kit. They're provided by the browser, and that is where the browser incompatibilities surface. So yes, there's a lot of hatred in JavaScript out there, but some of it is truly misguided. We shouldn't be hating the language, we should be hating the browsers. And we shouldn't be hating any of this, right? But we at least need to be able to explain why these incompatibilities exist. When Netscape originally came out, it had a 92% market share. It thought that it was the one ring to rule them all. It thought that web browsers were a zero-sum game in that they could have the entire market. And in fact, the first two browsers proved that point. Netscape had the overwhelming majority, and then IE went on to get an equally overwhelming majority. And the way these two behemoths argued with each other, fought for competitive advantage, and I don't use air quotes very often, but I will use competitive advantage in an air quote because the way they competed with each other is by building incompatibility into the browsers. As Netscape introduced new HTML5 elements, IE was forced to match those elements and add their own elements. And then Netscape was forced to add those IE-specific elements in its own as well. And what we ended up with were two major browsers running as fast as they could away from the other browser. But those were the bad old days. Here we are 20 years later now in the HTML5 era. What we find is all browser manufacturers are running as quickly as they can towards a common goal. They want to prove to the rest of the world how quickly and how fully and how robustly they can implement the HTML5 stack. And that's good because it's hard to arrange developer protests around issues like this. What do we want? RenderKit API incompatibilities. When do we want it? Never again. It's hard to chant. But what we have are a set of browsers that are working towards a common goal now. It's far better than it used to be. And all modern JavaScript languages finish the job that the browser manufacturers don't in terms of shellacking over those RenderKit differences. I'm talking about the jQueries and the Angulars and the backbones of the world. They all know that they're going to be running on disparate platforms, and they allow you to program to their API and polymorphically handle the browser differences under the covers. You can prove this to yourself. If you go into a browser, in any browser, and type in navigator.appname, you're going to get a name back. No guarantees that it'll be the proper name, but you will get a name back at least. And if you type in navigator.appversion, wow, there are so many lies in that user agent string, I don't even know where to begin. Clearly, I'm running this on a Mac. Clearly, I'm running this in Chrome. So when I ask it what version it is, it says it's version 5. Well, that's our first lie. It's not lying about being on a Macintosh. It's not lying about being on an Intel chip. But it goes on to say it's Apple WebKit? No, I don't think so. It goes on to say, well, we're based on KHTML, which is kind of like Gecko. Well, if you know all your render kits, what you have to do is just figure out which render kit they didn't mention and assume that's what they're using. In fact, I'm looking for Blink, but I don't see it anywhere. I do see Chrome, which is good, and that Chrome version is accurate, but then I see Safari right behind it. I don't know what to believe, but at least we know that these APIs are provided to us by the browser. If you were to turn around and run similar code like this in Node, you can create a file called navigator-test.js and try to console log a Navigator app name and a Navigator app version. And when you run it in Node, you'll hear sad trombones playing because it'll say, Navigator, what are you talking about? We're not running inside of a browser. We're running headless, so I don't have a Navigator library available to us. Now, I often go to MDN, the Mozilla Developer Network, for my JavaScript APIs, even though ECMAScript, the European Computer Manufacturers Association, is the specification. We're currently on ECMAScript 5 or ES5, but ECMAScript 6 is due to be ratified, due to be finalized in this month, March of 2015. And so ECMAScript 6 is right around the corners, but ECMA is the standards organization. The reference implementation continues to be SpiderMonkey, continues to be the JavaScript engine coming out of the Mozilla Foundation. So I find using their documentation to ask questions about JavaScript is very powerful. So we can see right here that Navigator, if we ask for app name, if we ask for app version, it returns these versions, but they say do not rely on this property to return the correct value. Truckers, don't be fooled. Yeah. But these are where we would go to learn about the browser APIs available to us. You would go to nodejs.org to find out what APIs are available to us there. And as I'm looking through this list, I don't see Navigator, I don't see Window, I don't see Document, but I do see interesting things like OS. And if I dive a little bit deeper into that library, I can ask for things like OS hostname, OS type, OS platform, OS architecture. And when I run this script now in Node, I do get a different set of answers. So what have we learned here? Well, we've learned don't hate the JavaScript, don't hate the language, hate the incompatible APIs provided by the platform. And while we're talking about platforms, it's important to recognize that JavaScript, the core language, it is what's consistent across all tiers of our mean stack. But we'll find that the APIs included vary from platform to platform. And that's what you would expect.